Hello, Algebra 2. This is section 753, which is multiplying complex numbers. So we're multiplying numbers that include imaginary parts. So by the end of this, you should be able to do that and simplify your answers. So a few things to remember. Whenever you're multiplying imaginary numbers, or complex numbers rather, any square roots of a negative number are going to turn into I and then the square root of that number. So anytime you have the square root of a negative number, you always want to pull your I out first and try to simplify that square root as much as you can, and then go about your multiplication. And then there are a few other things that we can excuse me, that we can talk about. I has a pattern within its exponents, within its powers, that repeats itself every 4 powers. So we know that I is the square root of -1. So I squared is -1. So I cubed, well, I cubed is the same thing as I squared times I to the 1, right, which is -1 times the square root of -1, which turns into -I. So then I to the 4th, well, that's the same thing as I squared times I squared, which is the same thing as -1 times -1, which is a +1. And then we could run through this pattern again, and we could say, well, I to the 5th, if this pattern repeats itself every 4 units, then I to the 5th, going back to the top, is I cubed is going to be, or I'm sorry, I to the 6th rather, I to the 6th is going to be -1, I to the 7th is going to be -I, and then I to the 8th is going to be a +1. And so you have this pattern of I, -1, -I, 1 that repeats itself every 4 exponents, or every 4 powers, right? And so then I could start over and I could say, well, I to the 9th, well, that's going back to the top of this order. That's I to the 10th is going to be -1, I to the 11th is -I, and then I to the 12th is 1 again. And one way that we could do this to figure out large powers of I without having to run through this pattern is you could just break it down to the closest multiple of 4. So, for example, let's say we're trying to figure out I to the 721. Okay, I to the 721. Well, if we work backwards from 721, the next perfect multiple of 4 is 720. So I to the 721 is the same thing as I to the 720 times I to the 1, right? And you know, when you're multiplying things with the same base, you can add your exponents, and 720 plus 1 gives you 721. So that's why that works out that way. And so you know, well, anything that is a multiple of 4, any I powers that's multiple of 4 is just 1. And then from this pattern of the first 4 powers of I, you know that I to the 1, well, that's just I, and so our answer is I. Okay, and so we could do this again. We could think of some large number that's, let's see, how about I to the 333, okay? So, we work backwards from 333 to the next perfect power of 4, so this is going to be I to the 332 times I, let's make this interesting. Let's go I to the 334. Yes, we'll do I to the 334 is I to the 332 times I squared. And we know I to the 332 is 1. And I squared, looking at our pattern here, well, that's -1, so then your answer is just -1. Okay? So you work backwards to your next perfect power of 4, and then you take your remainder and multiply by that. So that's what that chart on the first page of your handout about the powers of I is all about. And the other thing that we have to talk about is whenever you're trying to simplify the radical of a negative, the first thing that you always want to do is pull the I out. And that makes a difference. The order that you do it in will make a difference in your final answer, especially when you're dealing with a lot of negatives. So let's say, for example, we have the square root of negative 6 times the square root of negative 4. So the proper way to do this is to pull my i's out. I root 6 times I root 24, okay? And then I can group my i's together, so I have I times root 6 times 24. Put all of that under one radical. And I times I is I squared. And 6 times 24 is 144. And I squared is the same thing as negative 1. And the square root of 144 is 12. So your answer is negative 12. So this, what we just did right here, is the correct way to go through this problem. The incorrect way, and you probably don't even want to write this down, but just watch this. So let's say we start with the same problem. Negative root 6 times negative root 24. So the incorrect way to do this would be to do this multiplication within our radicals without taking the i's out first. So if we do this first and we don't take the i's out, well, a negative times a negative is a positive. So then you're doing the square root of positive 144, which is just positive 12. Okay, so there's a big difference between positive 12 and negative 12. So this is incorrect. So you don't want to do it this way. So it does make a difference whether or not you pull your i's out first, and you should always do that first. Alright, so we're going to go on to the classwork and do as many of these as we can. So some of these are pretty straightforward. Alright, so problem like number 1, we have excuse me, 5i times negative 8i. Well, I can multiply my real parts. 5 times negative 8 is going to be negative 40, and then I times I is I squared. And you know I squared is the same thing as negative 1, so you have negative 40 times negative 1, which turns into a positive 40. Alright, let's go on to number 2. We have negative 5i times negative 3i. So negative times a negative is a positive, so you're going to get 15, and then I times I is I squared, and so you get negative 15. For number 3, we have negative 8i times 20, okay? So negative 8 times 20 is negative 160, and then you have that I, so your answer is just negative 160i. Moving on to number 4. So for number 4, we have negative 4i times negative 8i. So negative 4 times negative 8 is a positive 32. And then we have I squared. So I squared, remember, is the same thing as negative 1. So this answer is going to turn into a negative 32. Going on to number 5, we have the square root of negative 3 times the square root of negative 27. So the first thing we want to do here is pull our i's out. So this is going to be I root 3 times I root 27. So then we can group like things together, and so we would have 2 i's out in front, and then we can take our 3 and our 27 and multiply them underneath one radical. Okay, so I times I is I squared, and then 3 times 27 is 81. So moving this down here, well, I squared is the same thing as a negative, and then the square root of 81 is just 9. So your answer is negative 9. So going on to number 6. So for number 6, we have a similar type of problem. I've got the square root of negative 2 times the square root of negative 32. So the first thing we want to do is pull our i's out. So we'll have I root 2 times I root 32. And so we're going to take the two i's, put them out in front, so I'll have I times I, and then I'll have 2 times 32 all under one radical. So the I times I becomes I squared, and then the 2 times 32 becomes 64. So I squared turns into a negative 1, and then square root of 64 is 8. So your answer is negative 8. For number 7, we have the square root of negative 6 times the square root of negative 8. So if we pull our i's out, we'll have I root 6 times I root 8. So we pull the i's out in front, and 6 times 8 is 48, okay? So I times I is I squared. And then root 48, well 48 we can break that into 16 times 3. And then the square root of 16 is 4, so we can pull that out in front. So we have 4I squared root 3. And we know I squared is the same thing as negative 1, so we can just rewrite this as negative 4 root 3. Alright, so number 8 looks a little different. This is going to take some distribution. So we have 3I times 5 plus I. So what we're going to do is we're going to take this 3I and distribute that across our parentheses. So that'll give us 15I plus 3I squared. So that I squared is going to turn into a negative. So then you'll have 15I minus 3. And you can leave your answer like that. You would get full credit for that. But when we have complex numbers that include imaginary parts and real parts, we really prefer to put the real part first. So a better way, maybe a more sophisticated way to write it, is to put your real part first and to rewrite this as negative 3 plus 15I. For number 9, we're going to have 4I times 2 plus 3I. So we're going to take this 4I and distribute that across, and so that will give me 8I, and then 4 times 3 is 12, and then I times I is I squared. Okay, so I have 8I. Well, this I squared becomes a negative, so then that can turn into negative 12, and again we would really like to write our real part first, so this is going to turn into negative 12 plus 8I. And that's it for number 9. Let's see. So we'll go down here and we'll go on to number 10. Now number 10 is different than anything we've seen before. What we're going to have to do is FOIL that stuff. Okay, so if we multiply our first, 5 times 3 is 15. My outers, 5 times I, that'll be plus 5I. My inners, negative 2I times 3 is a negative 6I. And then my last, negative 2I times I, is going to be a negative 2I squared. So simplifying this, we'll get 15. 5I minus 6I is minus I, and then negative 2I squared, well that I squared turns into a negative, and then you already have this negative out in front, so you would have a double negative, so it's kind of like having minus a negative 2. So this turns into 15 minus I, double negative is positive, right? So we can combine 15 plus 2 and we'll get 17, and then we have 17 minus I. So for number 11, we have the same type of problem. We're going to have to FOIL. So I have 4 plus 3I times 3 plus I. So my first, 4 times 3 is 12. My outers plus 4I. My inners plus 9I. And then my last, 3I times I plus 3I squared. So I'm going to have 12, and then 4I plus 9I. Well, 4 plus 9 is 13I, and then 3I squared, that I squared becomes a negative, so minus 3. So 12 minus 3 is 9, so I'll have 9 plus 13I for number 11. For number 12, that's going to be one that we're going to have to FOIL out. Alright, so for number 12, we have 5 minus I squared, which is the same thing as 5 minus I times 5 minus I, and so we can FOIL this out. So if I do my first, 5 times 5 is 25, my outers is negative 5I, my inners is negative 5I, and then my last, negative I times negative I is negative I squared. So simplifying this, I'll have 25, and then minus 5I is minus 10I, and then negative I squared. Well, we already have this negative that's right here, and then the I squared itself turns into a negative 1. So now we have 25 minus 10I, and then this double negative becomes positive, so that becomes plus 1. So 25 plus 1, we're going to have 26 minus 10I, and that's our answer for number 12. Going on to 13, this is another FOIL problem. So I'll have 5 minus I times 2 minus I. So multiplying my first, 5 times 2 is 10. My outers, that'll give me negative 5I. My inners will be negative 2I. And then my last, well, the double negative, that'll be positive I times I is I squared. So I'm going to have 10 minus 5I minus 2I is minus 7I plus I squared. Well, that'll turn into a minus 1. So 10 minus 1 is 9. So I'll have 9 minus 7I as my answer for 13. For 14, we're going to have 3 minus 4I times 2 minus I. So if we FOIL this, so 3 times 2 is 6. My outers, 3 times negative I, negative 3I. My inners, negative 4I times 2. That'll be negative 8I. And then my last, negative 4I times negative I. That'll be positive 4I squared. So simplifying this, I'll have 6. Negative 3 minus 8, that'll be negative 11I. And then plus 4I squared, well, I squared is a negative, so that'll be negative 4. So combining like terms, so 6 minus 4 is 2, and then I have my minus 11I, so our answer is 2 minus 11I. Let's go on to 15. So for 15, I have 6 plus 2I times 6 minus 2I, okay? So 6 times 6 is 36. And then my outers, that's going to be 6 times negative 2I, so negative 12I. My inners, 6 times 2I is plus 12I. And then my last, excuse me, 2I times negative 2I, that'll be negative 4I squared. So I'm going to have 36 minus, well, actually, sorry, negative 12I plus 12I, that cancels out. And then I have negative 4I squared, so I'm going to already have that negative 4. And then this I squared becomes a negative 1, so it's kind of like you have another negative right there. So this is going to turn into, this double negative becomes a positive, and this will turn into 36 plus 4, which is 40. Okay, so your answer to number 15 is 40. Let's take a look at 22. We've got fractions. So for 22, I have 1/2 plus 2I times 2 plus 1/2I. Okay, so if we multiply the firsts, 1/2 times 2, well, that's just 1. My outers, 1/2 times 1/2I, so that'll be plus 1/4 I. My inners, 2 times 2I, that'll be plus 4I, and then my last, 1/2 I times 2I, well, 1/2 times 2 is 1, so that's going to be plus 1I squared. So simplifying this, I'm going to have 1, and then 1/4 I plus 4I, well, let's see, 4I is the same thing as 16 over 4. 4 is the same thing as 16 over 4. So 16 over 4 plus 1/4, that's going to be 17 over 4I. And then plus I squared, well, that'll turn into a minus 1. So your answer for number 22, because your 1 and your minus 1 cancel, will just be 17 over 4I. Alright, so that's 22. We can take a look at 23 and 24. So for 23, we have 3 minus 6I times 2 plus 5I. So this is going to be one that we'll have to FOIL. So 3 times 2 is 6. My outers, 3 times 5I is 15I. And then my inners, negative 6I times 2, that's going to be negative 12I. And then my lasts, negative 6I times 5I, that'll be negative 30I squared. Okay? So we can go ahead and simplify this. So, let's see. Okay. So, let's see. I'm going to have 6. 15 minus 12. That's going to be a positive 3I, and then negative 30I squared. Well, we already have that negative. I squared turns into another negative. So, it's kind of like you have 6 plus 3I plus 30. So 30 plus 6, we'll get 36 plus 3I as our answer for 23. So last problem, 24. We have 3 minus I times 1/3 plus 2/3 I. Alright, so multiplying first. So 3 times 1/3 is 1. My outers, 3 times 2/3 I, that's going to give me plus 2I. My inners, negative I times 1/3, that's negative I over 3. And then my last, negative I times 2/3 I, that's going to be negative 2/3 I squared. So I'm going to have 1 plus 2I minus 1/3 I. Well, negative 2/3 I squared, that's going to turn into plus 2/3, and 1 plus 2/3. Well, 1 is the same thing as 3/3. So 3/3 plus 2/3 will have 5/3. And then 2I minus 1/3 I. Well, 2 is the same thing as 6/3. So 6/3 minus 1/3. So that'll be plus 5/3 I. So that's your answer to number 24. And hopefully you've seen enough and you can go ahead and try the homework on your own.